There are different uses of plastics. Plastic is a type of polymer that can be pliable and easily shaped. It is made up of long chains of atoms that have repeating units, causing it to be strong, lightweight, pliable, and flexible. In 1869, the popularity of billiards skyrocketed and strained the supply of ivory. This led to an award of $10,000 for those who could find a substitute. This inspired John Wesley Hyatt and led to his invention of plastic. Now, there are 7 types of plastic which have different characteristics and purposes. Each type of plastic can be identified by these symbols. Polyethylene terephthalate, or known as plastic polymer, is usually used for bottles, jars, microwavables, and caps. High-density polyethylene, which is usually much stronger and thicker than PET, is used in grocery bags, shampoo bottles, agricultural pipes, and milk jugs. Polyvinyl chloride can be rigid and flexible. It is largely used in the building industry to produce doors, window profiles, and pipes for plumbing. Low-density polyethylene, which has low-density molecules, is thinner and more flexible. It is used in six-pack rings, shrink wrap, and food wrap. Polypropylene is used in hard and sturdy applications. Several examples are Tupperware, car parts, thermal vests, and yogurt containers. Polystyrene, or better known as styrofoam, can be found anywhere due to its inexpensiveness. Beverage cups, insulation, packing materials, egg cartons, and disposable dinnerware are some examples. Any other plastic that doesn't belong to the first 6 types and polycarbonates that are used in lenses, safety, and sports glasses belong to this group. Plastic found in mobile phones and CDs also belongs in this type.
Whenever you look, you can see plastic being used from medical supplies, food packaging, electronics, appliances, and everyday items. Plastics has become woven into the fabric of modern life. The use of it has been growing exponentially in the last century. Since the 1950s, the annual production of plastics has increased nearly 230-fold to 460 million metric tons in 2019. However, like any other thing, the use of plastic has its downside. It is a non-biodegradable material, resistant to nature's cycle of decay. Once produced, it does not simply disappear. It lingers for centuries, even millennia, accumulating in landfills and oceans alike. In 2022, National Renewable Energy Laboratory, 86% of plastics end up in landfills. Plastic pollution is a global problem as substantial amounts of plastic waste enter the marine environment and leak into the ecosystem. Once there, it poses serious threats to all living things. Marine animals ingest plastic debris, mistaking it for food or becoming entangled in it. On top of that, plastic contamination disrupts natural processes, like reducing ecosystems' capacity to adapt to climate change. PET plastic is one of the biggest culprits behind our growing mountain of plastic waste. Every year, millions of tons of PET bottles and packaging piles up, with the usage soaring from 19 million metric tons in 2015 to an expected 36 million by 2030. That is a tidal wave of plastic, and most of it ends up buried in landfills or drifting through our oceans. But recycling can change and improve this, because instead of letting it pollute the planet, it gives PET plastic a second life.
PET, aside from being the most used plastic, is also the most recyclable due to its polymer chain breaking down at relatively low temperatures, allowing it to be recycled numerous times during its lifespan. Recycling PET conserves resources, saves energy, and curbs pollution. Each stage, from collection to cleaning, keeps plastic out of landfills and oceans, cutting greenhouse emissions while giving waste a second life as a new sustainable product. The process of PET recycling can be done easily through mechanical and chemical means. It involves collecting, sorting, and then mechanically or chemically processing plastic to create new products. Mechanical recycling involves shredding the PET into flakes, washing, drying, and then melting and reforming them into pellets, or new products like fiber or sheets. Chemical recycling then breaks down the PET molecules into their original monomers to be repolymerized. The recycling process consists of several key phases that ensure safety, efficiency, and quality in producing new materials from discarded plastics. It begins with collection and transportation, followed by sorting, using manual and automated systems to separate plastics by type and color. The materials then go through washing, which removes labels, glue, and dirt, and then grinding, where plastics are shredded into small flakes. These flakes are melted and remolded into uniform pellets during the pelletizing phase, creating reusable raw materials for manufacturing new plastic products such as bottles, fibers, and packaging. The first phase of the recycling process is collection and transportation, which ensures a steady flow of recyclable materials to processing facilities. Many cities provide curbside pickup programs, while drop-off centers and recycling bins are available in public areas for added convenience. Once gathered, these PET plastics are transported to recycling facilities where they are weighed, inspected, and prepared for sorting and cleaning. This stage is essential for maintaining an efficient recycling system and reducing contamination. Once PET plastics arrive at the facility, they go through pre-sorting and sorting. Pre-sorting begins with serrated shears, which slice open bags of recyclable waste during their journey along the conveyor. The contents then fall into a metering rocker, where smaller pieces fall onto the conveyor below, leaving the large items above to be sorted by weight. During this process, operators survey the material on the conveyor, removing any non-recyclable material and contaminants, separating paper and metal to be recycled at the appropriate facilities. After pre-sorting, recyclable waste advances into the automated sorting system, where the machinery ensures high-quality PET recovery. This process starts with a pair of magnets. Magnetic and eddy current separators remove both ferrous and non-ferrous metals that could contaminate or damage downstream equipment. The materials then pass through the air classifiers, which employ controlled air streams to separate lighter materials such as paper labels, plastic films, and fine dust from the more dense PET bottles and fragments. The materials then proceed through a near-infrared system where scanners analyze the light. Reflection of the plastic identifies PET from other plastics like HDPE, PP, and PVC. Finally, optical color sorters identify the color of each PET item and use bursts of air to separate clear, green, and blue plastics into different channels. Clear PET is an especially valuable color due to its purity and versatility that allows it to be easily transformed into new transparent packaging and high-grade recycled products. After the sorting process, the PET materials undergo the baling process. This process uses a baling machine equipped with a hydraulic ram which compresses and binds loose PET plastic into dense rectangular blocks. Typically, each bale, which weighs 1,000 to 1,500 pounds, is bound with wire. Baling makes for efficient handling and transport, also reducing storage space. After this process, the bales are transported to a specialized recycling facility. The next key phase is grinding. During this stage, the compacted PET is broken apart and fed into industrial shredders or grinders. Cut the plastic into small consistent pieces called flakes. This grinding process reduces size for easier handling and increases surface area, allowing contaminants like labels and residues to be removed more efficiently during washing. Following the grinding process, the material proceeds to the washing phase to ensure purity and quality. There's a hot washing stage where PET flakes are cleaned in heated chemical solutions, which would dissolve adhesives, oils, and other contaminants. Then it proceeds to a cold washing stage where it gets rinsed with cold water to remove loose dirt and chemical residue. For further cleanliness, a high-speed friction washer is used to remove fine impurities and improve surface quality. Then it goes to a centrifugal dryer, which spins at high speed to remove excess moisture. Finally, air separation and quality control are performed with air classifiers and vibrating screens eliminating dust, labels, and non-PET particles to ensure the final PET flakes meet strict quality standards for use in manufacturing. With the PET flakes now thoroughly cleaned, dried, and free from contaminants, the recycling process moves forward to the melting phase. In this stage, the purified flakes are subjected to high temperatures and pressures within specialized melting or extrusion equipment. The controlled heat softens and liquefies the PET, allowing the polymer chains to reform without significant degradation. This process transforms the solid flakes into a uniform molten plastic that can be easily molded or extruded into new shapes. After melting, the liquefied PET is directed into molds and cooling to form uniform pellets. The molten plastic is extruded through molds or die heads into long strands, which are quickly cooled using water or air to solidify. The hardened strands are then cut into small pellets, known as resin pellets or nurdles, which serve as raw material for producing new PET products like bottles, fiber, and packaging.
Even though global recycling rates are still low, PET recycling remains one of the strongest tools available for reducing plastic pollution. Data from end-of-life plastic trends show that as plastic production has rapidly increased since 1960, landfill disposal has grown alongside it, with 86% of plastics still ending up in landfills. Increasing PET recycling directly slows the growth of this waste stream. Recycling PET significantly reduces energy use and greenhouse gas emissions. Producing recycled PET requires far less energy than creating new plastic from petroleum, lowering carbon emissions and decreasing the pressure placed on fossil fuel resources. Over time, expanded PET recycling helps conserve energy and lessen environmental impact. Another major advantage is that PET recycling supports a circular economy. When PET bottles are collected, cleaned, and processed into flakes or pellets, they can be transformed into new materials such as packaging, food containers, textile, fibers, carpets, and construction items. This closed-loop system keeps plastic in circulation longer, reduces waste, and turns discarded items back into valuable resources. Recycling also drives economic benefits. Material recovery facilities, also known as MRFs, employ workers and advanced machinery to sort and process plastics, supporting jobs across the recycling and manufacturing industries. As recycling rates grow, these systems become more efficient and contribute to long-term environmental and economic sustainability. Despite its advantages, PET recycling faces major challenges. Contamination remains the biggest issue, as food waste, mixed materials, and plastic bags can damage the equipment or cause entire loads to be rejected and sent into landfills. Cost is another limitation. Domestic recycling requires expensive sorting technologies, specialized washing systems, and consistent maintenance, making it less profitable in many regions. Without financial support or long-term investment, recycling systems struggle to operate efficiently. There is also a public misconception that most plastics are recycled, when in reality, recycling rates remain low. This creates an illusion of progress while the majority of plastic still enters landfills. Short-term economic priorities often outweigh long-term environmental sustainability. Finally, mechanically recycled PET can weaken after repeated processing, limiting how many times it can be reused without additional treatment. This means recycling must be paired with reduction, reuse, and improved product design to effectively manage plastic waste.
Recent innovations in PET recycling are significantly expanding the efficiency, quality, and sustainability of plastic recovery. Companies are now developing proprietary depolymerization technologies capable of breaking down plastics into their original chemical building blocks, regardless of contamination or material complexity. This approach enables the production of virgin quality PET, greatly increasing the range of plastics that can be successfully upcycled. AI-driven sorting systems and smart recycling infrastructure further enhance this process by accurately identifying and segregating plastic types, improving both speed and accuracy in recycling facilities. A notable breakthrough comes from the startup Green, which developed microwave-assisted depolymerization, a process that uses microwave energy to break PET down into its fundamental monomers, terephthalic acid and monoethylene glycol. These monomers can be recombined to produce high-purity, food-grade PET pellets, supporting a more circular and sustainable plastics economy. Recycling PET is essential because it provides major environmental and economic benefits. Using just 1 pound of recycled PET flakes can reduce energy use by 84% and cut greenhouse gas emissions by 71% compared to producing new PET. Continuous recycling conserves raw materials, lowers reliance on petroleum, and reduces the environmental impact of extracting and manufacturing new plastics. Since turning recycled PET into flakes or pellets requires far less energy than processing most other plastics, consistent recycling directly reduces emissions. Overall, keeping PET in the recycling loop helps minimize waste, lower carbon footprints, and support a more sustainable, circular economy. Recycling PET at home begins with the simple habits that make a big difference. Rinsing bottles, removing caps when possible, and keeping recyclables clean helps prevent contamination and improves recycling quality. Separating PET from regular trash and choosing products packaged in recyclable PET also supports the system. Even reusing containers before recycling them reduces waste. These small actions help reduce landfill use and contribute to a cleaner, more sustainable environment. Ultimately, combining modern technology with responsible consumer behavior allows us to reduce waste, support a circular economy, and move towards a more sustainable future.